Assalamu alaikum. Good afternoon, everyone. My name is Jenan. I'm sorry if you're expecting a break, but I'll be quick, inshallah. First of all, I'd like to thank my Brunel supervisor. I'm glad that she's here with us today, Dr. Tatiana. And unfortunately, my Ahliya supervisor could not make it, Dr. Awasan. So, first of all, starting with I'd like to share some interesting facts with you. Living in an era of technology, there are billions or a massive amount of data that is being produced every day. And according to the World Internet Usage and Population, there are over 4.5 billion users on the internet. And I assume that you're one of them. So can you think of how much data does that produce and how useful would it be if the appropriate mining techniques were applied, whether it was data mining, text mining, web mining, or graph mining, which I will be focusing on in my research. So graph mining is basically extracting useful information out of graphs. And a graph is a representation of a network. And in each network, there are some nodes that tend to be closer together than the rest of the group. These nodes form a community. So one community nodes or one community member tend to have the same behavior, same choices, same interests, or taste. Okay, so the problem is, or the community detection problem is, how to detect communities out of this network. To formulate our problem, let's say this is our network. And to detect communities, we will have a multiple number of communities. Now, this is a perfect scenario, which is not always the case, because in real life, a node can belong to more than one community at the same time, which will cause the overlapping. And we'll talk about this problem later. Now, why community detection is important, or why do we detect communities? Actually, it gives some significant results in health sector. Of course, when the networks are biological networks rather than human networks, for drug discovery and disease detection and treatment at early stages. In criminology, they were able to detect fraud and terrorist activities. Also in marketing for customer segmentation, smart advertising, and targeted marketing. It also improved the recommendation systems in e-commerce, in social network analysis, network summarization, and privacy. This also helped in re-identifying multiple addresses for the same user in Bitcoin. Also in link prediction and community evolution prediction. In my research, I will focus more on the social network. Okay, so basically the network is going to be, the nodes are going to be people, and the relationship between each node is, between two nodes is an edge. Okay, and the data sets will be real world data sets and synthetic data sets. Now for classification of the algorithms, researchers used algorithms to find disjoint communities and overlapping communities. And it's clear that the overlapping was not given as much attention as the disjoint community. Here I highlighted the most used algorithms in the literature, which are basically evolutionary algorithms such as neural network, genetic, quantum, and particle swarm. And by reviewing the future scope of these researches, I found that most of them tend to or lack the detection of overlapping communities, which they mentioned in their future work that they will do. The others suggested that they will improve time or give a node importance, or will try the algorithm on different network types, whether it was a large scale, small scale, or a dynamic network. Now, in my research, I will try to combine more than one algorithm, more than one method to overcome this problem, to solve the overlapping community detection using the multi-objective algorithms. Now, how to evaluate the method, or how do we say that the detected communities are accurate? There are actually two common formulas used. The first one is modularity, which is the number of edges falling within group minus the expected number of edges, and it can be calculated using this formula. The other one is basically a matrix, the normalized information. It's a matrix where rows correspond to real communities and columns correspond to the detected communities. There's also a formula for that. And there are some researchers that suggested or proposed some evaluation methods, but they did not get as popular as these two. So the research question will be, can the accuracy of community detection in social networks be improved by using hybrid intelligent techniques? And then if the answer is yes, then how would it be improved? It would be through the proposed algorithm. Now, the methodology to do that is to review the related work, as I've already done, and then now I'm at the stage of designing an algorithm to solve it, implement it, and then analyze the results. Thank you so much.